So, welcome to our discussion of econometrics once again. In our previous class, we were basically discussing about what is econometrics, and then we said that econometrics is basically an application of mathematical and statistical tools to analyze economic data for the purpose of measuring empirical validity of economic theory, right? Empirical validity of economic theory. And then we have also discussed about in detail what exactly is economic data, and we said that economic data is basically a data that is generated out of economic decision making, and we have discussed several examples of economic data. These are the examples we have discussed, all right. And then we have also discussed about what are the three major objectives of econometric analysis. First of all, drawing inference about the population parameter in the context of consumption function that we are discussing, where we said that y equals to alpha plus beta x. Alpha and beta, they are the true population parameter which are unknown, and we are trying to draw some kind of inference about the true population parameter on the basis of our sample statistic alpha hat and beta hat that we are going to estimate. And then we are also going to make some kind of establish some kind of causal relationship between the dependent and independent variable. In this example, the causal relationship between income and consumption, that is also we are trying to establish through econometric analysis. And then lastly, econometric analysis helps us forecasting, and regarding this forecasting, we have to keep in mind that a related concept is prediction. So, while prediction is applicable mostly in the context of cross sectional data, that means when you have information on income and consumption, let us say for 100 individuals. So, after estimating the model, we can predict if someone some individuals income is 750 rupees per week, then what should be the individual's consumption. So, that is what is called prediction, which is applicable in the context of cross sectional data. But when it comes to forecasting, we have to keep in mind that forecasting is basically applicable for time series data, where we are going to use the past data of a time series macroeconomic variable, and then we are going to predict the future values of that. For example, if we have India's GDP for let us say 10, 15 or 20 years, then what we are going to do? We are going to forecast India's GDP in next year or next to next year, like that. So, that means forecasting and prediction, the only difference is the time dimension. While prediction is applicable for cross sectional data, forecasting is basically applicable for a time series data. So, forecasting is nothing but prediction about the future outcome. That is what we have to keep in mind in this context. Though we are using these two concepts interchangeably in this basic econometrics course, prediction and forecasting, they have a difference in terms of their time dimension. So, forecasting is nothing but prediction about the future. Okay. Like we say that weather forecasting, it is not weather prediction. So, we use past data of weather and then we try to predict about the future weather, which is called weather forecasting. Okay. Forecasting. And then today what we are going to discuss is what are the different steps that are involved in an econometric analysis. If you recall, we said initially that econometric analysis is like any other scientific analysis. So, firstly what you have to do, you have to observe certain things. For example, when you are talking about income and consumption, we observe how people consume, how people earn, and then with increased amount of income, how people spend, right. And after this type of observation of individuals' consumption pattern, then what we have to do in econometric analysis as a first step is to hypothesize some kind of causal relationship between income and consumption. So, this hypothesizing what we are hypothesizing is basically based on observation. We are observing certain things about the social individual's behavior, and then out of that observation we are trying to formulate some kind of hypothesis. That is the first step, right? That is the first step, hypothesizing a causal relationship. Now, once again, as we discussed earlier, that econometric analysis per se will not tell you the direction of causality. That means, when you have income and consumption, these two variables, we do not know whether it is income causing consumption or consumption causing income. So, that means you have to set the model, you have to specify which is going to be your independent variable and which is going to be the dependent variable, and that kind of hypothesis you have to make based on your own knowledge or based on existing theory or existing literature. Let us, for example, assume in our context that we are hypothesizing a causal relationship between income and consumption, and we are also assuming the direction of causation runs from income to consumption. That means, income causes consumption, consumption is the dependent variable and income is the independent variable. When we say y equals to alpha plus beta x, that means we are saying, when you are saying y I equals to alpha plus beta xi, y is consumption and x is income. So, it is basically income causing consumption. That is the kind of hypothesis we are making, right. So, this is the step 1 what we have written, that once you specify this type of hypothesis, that income causing consumption, then the next step, as we have mentioned here, y equals to alpha plus beta x is the next step. That means, formulating a mathematical model. What is the mathematical model? This is the mathematical model, y equals to alpha plus beta x. Okay. So, our hypothesis here is that we are assuming income causes consumption. That means, when income increases, with increased amount of income, individuals spend more on consumption. As income increases, consumption also increases, but less than proportionate. If there is an increase in your income by 1 rupee, probably individual's consumption will increase by 50 paise, 60 paise, 70, 80 or 90 paise. That means, less than 1 rupee. That is what is our hypothesis. Okay. And this kind of hypothesis, long back John Maynard Keynes, he made this hypothesis. That is why it is called Keynesian consumption function. Actually, he made this hypothesis, and then once you made the hypothesis, you have to make the mathematical model, which is the second step. This is the second step, formulating a mathematical model, y equals to alpha plus beta x, right, where y is consumption, x is income, and the restriction what we are imposing on the alpha and beta. Look at the restriction what we are putting. This is the restriction, a is greater than 0 and b is greater than 0 but less than 1. Okay. B is greater than 0 but less than 1, that restriction is actually implying our hypothesis, right. And this b, the coefficient which is attached with income, it has a specific name in the literature of macroeconomics. It is basically called marginal propensity to consume. That means, for a unit change in income, how much your consumption is going to increase. That is called marginal propensity to consume, or MPC. If you differentiate this function with respect to x, that means basically you will see that delta y delta x equals to b, which is nothing but the marginal propensity to consume. Then what is the next step? Next step, if you look at, after formulating the mathematical model, we need to convert that mathematical model into a statistical one. Okay? The mathematical model you need to convert into a statistical one. Why this is so? Because the mathematical model this y equals to alpha plus beta xi, this is kind of exact relationship between income and consumption. That means if you estimate this model, you will get there alpha hat and beta hat as the estimates of alpha and beta. So, once you estimate your model, if I tell you some values of x, which is let us say 600 rupees, then you would be able to exactly predict what is going to be the individual's consumption. But in reality, even if you know somebody's income, do you think that it is possible to exactly predict somebody's consumption? Probably no, because in reality individuals' consumption depends not only on income but also many other factors like taste and preference, then the price of related products, then individuals' education, gender, sex, so on and so forth. So, that means there are many variables there are many factors which will also have some kind of impact on the individual's consumption, which we have not included in this model. Even if you include 100 such variables, there will always be some variables left out of this model, because all the factors, it is impossible to think and imagine all the factors that will have some impact on individual's consumption. So, you may not have data for all the factors, you may not imagine all the factors, and even if you can imagine all the factors, some factors might be unobservable. For example, I can imagine taste and preference, but how do I measure? How to measure somebody's taste and preference? So, because of all these things, there will always be some omitted variables in your model, and for that you cannot exactly predict somebody's income. That means we need to convert that convert the mathematical model into a statistical one by adding some kind of error term. And how do you do that? Y equals to, sorry, this is the mathematical model, then the statistical model would be yi equals to alpha plus beta xi plus ui plus ui. This ui, this is called a stochastic error term. Stochastic error term, and that ui basically captures the influence of all other omitted factors that might also have some impact on your consumption, right. The moment you add the error term, your mathematical model becomes a statistical one, and journey of econometric analysis starts from actually here. So, entire econometric analysis evolves around this stochastic error term. So, even though ui is called the error term, it has the most significant influence, it is the most important factor in an econometric analysis that we have to clearly keep in our mind. What I am saying, the moment you add error term in the mathematical model, your mathematical model becomes a statistical one, and the journey of econometric analysis starts from here. from this statistical model, right. And the error term, it captures the influence of all other omitted variables that might also have some impact on consumption. And what we know about this error term? Error term is not a complete black box, rather we know certain things, two important things that we assume about the error term. Firstly, we assume that expectation of ui given xi is basically 0, okay. Conditional mean of the error term is 0, and then ui follows a normal distribution with 0 mean and some sigma square variance. That is what we know about the error term. So, the distributional assumption about the error term is known in this entire econometric analysis. Unless we know the distributional assumption properties of the error term, it is really not possible to go for econometric analysis. That we have to keep in mind, right. And why do you assume the error term to be followed normal distribution? Because of some convenience and some statistical properties. As you know that any distribution tends to follow normality as sample size increases because of the central limit theorem, which we are all aware of. And secondly, normal distribution, it has some standard properties for which the remaining steps of our econometric analysis becomes easier. So, we will discuss the importance of normality in a later part of our discussion. For the timing, we just have to keep in our mind that error term, it captures the influence of omitted variable, and secondly, we know the distribution properties of the error term. It follows a normal distribution with 0 mean and sigma square variance. Once you formulate the statistical model, then the next step is basically collecting the data, okay, data collection. When you are interested in estimating a consumption function, then you need to collect the data on income and consumption. And how do you collect data? That means data structure. There are three ways by which actually you can collect data. The first type of data what you can collect is cross sectional data, okay. There are three ways: cross sectional data, time series data and panel data. So, let us see each and every type of data, because depending on your data structure we will have a separate econometric analysis. So, what is cross sectional data? Cross sectional data is basically data collected across several individuals, but for a particular period of time. For example, if we are interested in consumption function, let us say that we are collecting income and consumption data from 500 individuals residing in Chennai in a particular point of time, let us say in November 2020. So, that means there is variation in your observation, in your data across individual, but there is no variation across time, because this data is collected only in a particular point of time, okay. But there is variation across individuals. Individual I might be having 500 as consumption and 1500 as income. When you go to jth individual's income is 2000 and consumption is 750. So, that means there is enough variation across individuals, but there is no variation across time. If that is the structure of your data, then that is called cross sectional data. Then time series data, it is just the opposite of cross section. That means here you have variation across time period, but there is no variation across entities. Why? Because you are collecting data only for a particular entity. and that entity might be an individual, might be a state, or might be a country. Okay? And you are collecting the data on income and consumption for the same entity over a period of time, let us say for the last 10, 15 or 20 years. Then the data will become time series data. And if you combine this cross section and time series, then you are going to get a cross sectional time series data or panel data, right? Panel data. So, that means in panel data you have characteristics of both time series as well as cross section. Okay? There is variation across entities, there is variation across time periods. If that is the case, then it is called panel data. But for our course of basic econometrics, what we are going to discuss here, please keep in mind that we are going to discuss econometrics taking a particular data set which is called cross sectional data. That is why our entire focus would be on cross sectional econometrics. The other two type of data we are not going to consider here because they come under the scope of advanced econometrics. We are going to discuss only cross sectional data in this particular course, right. Once you collect the data, the next step is basically estimation. So, what is estimation then? That means you remember we have specified an statistical model y equals to alpha plus beta xi plus ui. This is the model we have used, y equals to alpha plus beta xi plus yi equals to alpha plus beta xi plus ui. This is the model. What is happening? Some disturbance is given. So, yi equals to alpha plus beta xi plus ui. That is the model we are going to discuss, and we need to estimate this alpha hat and beta hat. That is called estimation. Okay? So, we are basically going to estimate the sample counterpart of the true population parameter alpha and beta. And what is the technique that we are going to use? We are going to use regression analysis. Regression. So, throughout our discussion on econometrics, there is a single technique for estimation, which is regression. The detailed procedure of regression we will discuss in detail in a later part of our discussion, but for the timing you just keep in mind that there is only one technique that is available to estimate this alpha hat and beta hat, which is called regression analysis. And we have to also keep in mind that we are going to estimate this alpha hat and beta hat from a randomly collected representative sample. That means, from a given population, let us say from Chennai, if your Chennai is your population, then from that population we can draw n number of samples of let us say 200 individuals. So, we are going to collect the sample randomly. Why this is so? Without random sampling, we cannot proceed for remaining steps of our econometric analysis that we will discuss later. So, for the time being, we have to keep in mind that we will collect a random sample from the population for our estimation, and the estimation we will do by the regression technique, regression analysis. And once you estimate the model, next step is the hypothesis testing. Next step is hypothesis testing. Now, for example, let us say that you have collected a sample of 200 individuals from the Chennai city about the income and consumption, and then you have estimated this type of model. So, that means here your alpha hat is equals to 0.50 and beta hat equals to 0.75. 0.75. Now, from this alpha hat and beta hat, do you think that the properties of Keynesian consumption function hypothesis, that means the hypothesis what you made earlier, is it established or not? This is the result. Now, apparently it may look like yes, our hypothesis is established, because beta hat value is 0.75. That means when your income increases by 1 rupee, your consumption increases by 75 paise, which is a significant amount. That means income is having a significant impact on consumption. And secondly, 0.75, it is lying between 1 and 0. So, that means from this value of beta hat, we can say that the properties of Keynesian consumption function is satisfied, because it looks like this. Your alpha hat is this is your alpha hat, and this is your beta hat, which is equals to 0.75. Let us say this is your consumption and this is your income. So, apparently you may think immediately after estimation that yes, the properties of Keynesian consumption function is actually satisfied. But statisticians and econometricians, they give some kind of caution to draw that type of inferences immediately after estimating the model. Why this is so? Because here you see you have drawn only one sample from your population, and in that population your beta hat value is 0.75. Now, it may so happen that if you draw another sample of 200 individuals from the same population, so this is, if this is your population, let us say this is your population, you can draw n number of sample, right, of 200 individual. These are all samples from the population, okay, these are all samples. These are all samples. You have drawn only one sample, let us say this is S1, you have drawn this sample, and in this sample it is 0.75. Now, it may so happen that if you collect another sample from this S2, there this beta hat value is like 0.005. So, you can easily understand that means for a unit change in income, consumption changes by 0.0005, which is very insignificant amount. That means this particular value of beta hat, which is 0.75, you may get purely by a chance factor. Purely by a chance factor, you have drawn one sample and in that sample it is 75, while there is no guarantee that in the next sample what you may collect of 200 individuals, beta hat will again come out as 0.75 or 0.70 or 0.80, or it may so happen that beta hat is even 1.005 in the next sample. That means I cannot rely the estimate that I got only from one sample. What I need to guarantee that even if I draw n number of samples from the population, in all the samples my beta hat value will come out to be significant. When I say significant, that means it is significantly different from 0, because if the beta hat value is 0, let us say 0.0000001, this is almost 0, okay, this is almost 0, and in that case what will happen, you have to say that no, my income does not have significant impact on consumption. So, that means we need to ensure that this 0.75 value what you got, that is not because of a chance factor, but for a statistical reason. That means we need to establish statistical significance of beta hat. So far what we see here is only mathematical significance. That means the magnitude of beta hat is different from 0. 0.75 is mathematically different from 0, but we need to ensure it is statistically different from 0. That means even if you collect other samples, in all other samples it will come out to be significantly different from 0. And how will you ensure that? After estimation you need to go for this step, which is called hypothesis testing, okay, which is hypothesis testing. The next step is going to be the hypothesis testing. That is why when we put this question, do you think this estimated consumption satisfy the property of Keynesian consumption function, then we have to say that actually this is not the case. This estimated consumption function, we cannot say that this is actually satisfying the property of Keynesian function unless and until we go for our next step, which is hypothesis testing.